So at this stage we have a rectangle object which when it's created, so we'll allocate two integers, the width, the height, and a pointer to dynamic memory where the copy of the provided string is going to be made. Okay, so this is the way our object looks like in memory. So internally has a couple of integers, has a pointer, and has a copy, manufactures the copy of the string used to initialize its memory. So now it's very important that when at the end of the day, at the end of our function, when the rectangle object is destroyed, so it's going out of scope, we need to be able to deallocate dynamically allocated memory. In order to make sure that this happens, whenever our structure is now part of its implementation is allocating and deallocating memory, we need to be able to capture the event when the object of this type is going out of scope. In C++, in addition to constructors, we can have a destructor. So destructor looks like this, tilde, and then followed by the name of the structure, and it has no parameters. So this is a signature or declaration of a destructor. Whenever object gets destroyed, its destructor is invoked. And in cases such as structure rectangle, which dynamically allocates memory to hold its name, we have to provide a destructor. Okay, and let's provide its implementation. So these are constructors, and this will be our destructor in the rectangle implementation file. Just like constructor, we prefix the name of the destructor with the scope of the rectangle class. So this is how destructor looks like in its implementation. Of course, we remove a semicolon and add a body right here. And what we really have to do inside the destructor, we just have to say that we want to delete memory associated with this dynamically allocated pointer like this. Okay, so just so this way, whenever the object goes out of scope, if this pointer holds memory, it will be deleted. Now we can also check this if the pointer is not null, right, and do this, but in reality it's okay to pass a null pointer to delete operator in C++, and the dynamic memory manager will ignore a request to delete memory if the pointer is set to null pointer. So in our case, of course, it's likely that it's not going to be null pointer. So this is why I think this is just quite enough to do it like this in our destructor implementation. So the destructor is the opposite of object constructors. We can have multiple constructors defined for our object because we'd like to be able to construct our rectangles with different sets of parameters. But there is only one destructor that we can define, and this destructor will be responsible for deallocating memory at the end of the object lifetime when the object is destroyed. So this is yet another issue that we have to be aware of when the structure allocates any memory dynamically. One important thing to also realize is that for us, in order to be able to call functions strlen and strncopy, we need to include this is part of C library, so we need to include C-string. So C-string is a C programming language library, inherited by C++ from the C programming language, and all functions that are dealing with string manipulation, like copy and length, can be defined in that specific way. So we can just remember to import the header file of C standard library. So I would like to try building this program, and the first error that I'm getting is related to the fact that the length here returns unsigned integer. So it's basically asks us to pay attention to this fact. So and it specifies that it's expecting to be accepted by the variable of type size t, which is the size of operator value type. So we'll just use size t to change it here. This is also an integer, but it's only a positive integer. And also the second error that we're getting on this line suggests that we define rectangle as to hold the pointer to a constant string. When we allocate memory dynamically, it's no longer a constant string. So what I'm going to do is to delete the constant qualifier here and keep the name as a non-constant, like a block of characters that can be modified. So this is something that we need to make in terms of changes to be able to control everything that we want to be able to control within this dynamic memory allocation logic. So let's build this solution, and so we get this other message that this function can be unsafe. I'm going to ignore. This is something Microsoft specific. So it gives me this example of a macro that I can add to our project to disable security warnings, which I'm going to do immediately. So _CRT, which is C runtime secure no warnings. I'm going to copy this directly from the output window, and I will go to our project properties, right? So this is the project properties of the project menu. And make sure that you switch all configuration to this, all configurations. And under C++ preprocessor, we're going to, instead of using this different options, we're going to edit this and simply provide this macro right here to disable unnecessary security warnings. I'm going to click OK and apply, and OK again, and this time build again. Okay, so now we're building fine. So hopefully this set name version is going to be doing fine. So let's do a very quick test on this program just to see where we stand with the latest changes. And in summary, these changes include the new destructor function, and the new version or updated version of set name with all the changes, and also the pointer is now just a pointer to a string of characters. It's not it's no longer a constant pointer. So let's do a very quick test. I'm going to press Ctrl F5 to run this program without debugging. And it's interesting that the generated version of the debug build is very kind to us because it detects a memory corruption issue. And so let's investigate what is happening here. So I'm just going to stop running this program, and it reports an error at the end, which is fine. But let me explain to you what we're dealing with is that when we're making a copy, okay, when we're manufacturing a copy of an object. The thing is that the copy constructor, which makes an exact binary copy of an object, is doing the following. So originally we allocate a rectangle object that looks like this, right? So it contains 3 data members, okay? These data members, okay, so it contains this. And when we say let's make a copy, essentially use this object as a prototype, so it manufactures an exact binary copy with exact bit by bit same memory content as the original object, right? So this is just a mirror image of the original object. Then this original object holds a pointer right here, right, pointer, to dynamically allocated string of characters, right? So there's somewhere the string of characters which it's dynamically allocating. And of course, because we're making this exact copy of an object, this pointer is exactly the same and also points to this memory. What happens is that at the end of the main function, right here, right, as we returning out of this function, the destructors of both of these objects, rect and rect2, are invoked. Now, because the rect was constructed earlier, its destructor will be invoked in the last turn. The latestly, the latter construct object, rectangle2, the most recent one, I should say, is going to be destroyed first, which is this guy. So right here, this box is going to be destroyed, and our destructor is programmed in such a way that it will deallocate this memory. So this object will be destroyed and its memory is deallocated. And then the second object, destructor, is also invoked, and it's going to realize that it needs to free memory, and it will attempt to free this memory the second time. So this is a really bad idea, because free store memory manager tells us in that exception that we get during the runtime when we try to run this program, that this leads to corruption of memory. The responsibility of a programmer who is going to use both new and delete. Okay, both new and delete. The issue here is that this deletion of memory has to happen only once, and you cannot delete the same memory twice. Therefore, we need to change the logic of our program in such a way that when we construct the first object, it's okay. We've been using it for quite some time already, and so it has the pointer which points to a dynamic memory, which is also fine. We were able to run this. But when we create a copy, okay, so when we make a copy of this object, what needs to happen, instead of using pointer to the same object, we need to be able to allocate its own memory, okay, give it its own dynamically allocated memory, and copy the contents from this string of characters, right, that was copied over here, right? So this was the string of characters that was copied from this static string, and now it needs to be copied to a brand new block of memory and stored internally by rectangle2. So this time, at the end of the day, when this closing brace is destroying all of the objects, and the most recent object is going to be destroyed, so its destructor will deallocate this memory, right? Will deallocate this memory, and this object will go out of scope. Everything is fine. The latter object also will be destroyed, and in its destructor it will deallocate this memory, and then this object will be destroyed, and this way there will be no corruption of dynamically allocated memory. And our next task is to provide a much safer version of this copying. Instead of relying on the default version of the compiler that makes this bit-by-bit copy for us, we would like to control the semantics of this copying, and in the middle of it we will generate a dynamically allocated memory, which will be placed under control of the new object, which we need to maintain in order to manage dynamic memory correctly overall in our program. So this idea of making copy like this is called a deep copy versus the default version, which is a shallow copy version.